Yes class, good morning. Today we will discuss here a new topic, composition of the function. First things, what is the composition of the function? Composition of the function here, when you directly relation of the two or more than functions. Composition function is not relation of the addition of the function. This one is not relation of the addition of the function. This one the relation of the directly relation of the two or more than the functions. First of things here, suppose two function here given, function f here given a to b and function g are given b to c. How to make directly relation of two a to c here? How to make directly relation of two a to c here? This process is called the composition of the function. So now how it is possible here? So b2 function, then the composition of the function fg means function f relation to function g. This process is called the composition of the function and denote by the GOF, or this relation will be represented by the GOF. Two relation here, GOF and fog. The fog is the inverted. I will discuss one by one. First we will discuss the GOF, then we will discuss the fog. Then GOF, denoted by the GOF, is defined as the function GOF a to c. So what is the process of being the composition function? Means a to directly to c. This is the domain or this is the codomain. What is the relation of a to c here? This is process is called the composition of the function. So now one more example I will give you here. Suppose any student here, suppose name here Ravi. This is the name of the student Ravi here, and here the board exam. This is your board exam, and this is your teacher. This one your teacher. So suppose this relation is called the function f, and this relation is called the function g. This relation is called the function g. This relation is the function f, student to board, and board to teacher relation is called the suppose function g here. That means board is represented by the a here, this one represented the b here, and this one represented the c. This process is called the composition of the function. But suppose your direct relation to student to teacher here, this is called the GOF. This process is called the GOF. Means student to teacher, direct relation of this. So this process is called the, suppose student give the exam, then board change your name and other numbers, or then give the teachers. Then teacher will check your seats, then give the boards, and boards also, then after that board send the result for you. So this is the process of the functioning. But direct relation student to the teacher is called here GOF relation. And suppose you are opposite process of this teacher to student. This process teacher to student. So this process is called the fog. This relation is called the fog. Teacher to student. This process is called the fog, and student to teacher relation is called the GOF. Understand these things. Okay, what is the composition of the function here? According to this diagram, you understand these things. Okay, students, you are direct not related to teacher here. In between student and teacher here, board, center board here. So then when you give the exam, the center your seats and go in the center board. Board give the teacher evaluate your seat, then again send back the board, and then board give you the result. In this process is called the composition of the function. Second example I will give you. First you note down it. Yes student, second example here. Suppose any two functions, suppose this function your x and second function your fx and third function your g fx, means this relation here is f, this relation here f, and this relation here function is g, this function name of the g. The directly relation function of this one also called here GOF. Now what is the different thing? Suppose f and g are are onto function, so GOF always will be the 1 1 and onto function. This relation a to c, what is the meaning of the GOF here? Meaning of the GOF here, this will be relation a to c. This is suppose a, this one suppose b, or this one suppose c. So direct relation is a to c is called the GOF. So then this is the called a to c. So means when f function f 1 1 onto function g is 1 1 onto, then GOF always will be, this is a fixed, GOF always 1 1 onto, then GOF always 1 1 and onto function. But suppose condition give is the reverse of this, कि GOF is 1 1 onto, but this is not always f and g is 1 1 onto function. This is not always. This condition is given कि f and g is 1 1 onto function. Then you can the result find out the result here, GOF always the 1 1 onto function. But when suppose condition is given reverse of this, if GOF is 1 1 onto function, so then this is not fixed. This is not always. F function f and g is always the 1 1 onto. Maybe function f is 1 1 function, not onto function. Suppose function is not 1 1, function g is not 1 1, but function g is the onto function. That means this function is the, suppose condition given that GOF is 1 1 onto, the function f is 1 1 not onto, but your function g is not 1 1 but onto. Maybe 1 1 onto both. So this condition is, reverse condition is not always satisfied, but this condition always satisfied. The function is f and g is 1 1 onto, then function is GOF will be always 1 1 and onto. Second thing, how to define this to function GOF is 1 1 onto? So then suppose value of the GOF, suppose value of the GOF how to find the function of this GOF? Value of identity function of the x. Suppose value of the GOF is identity function is the x, I inverted x, and for value of the identity function of the y, then you can say function is 1 1 onto, and function is also is the invertible function. What is the invertible function? Suppose function here f is tend to b and function b here b to a. In this type function is called the function a to b and some function b to a. Then in this type function is called the invertible function, and this function is always an invertible function and 1 1 onto function. Invertible function is always 1 1 and onto function. Invertible function is always 1 1 and onto function. So suppose function form in this form, if function f is a to b and function g is to b to a, then the function f and g is called the invertible function. So what value of the g? The g will be f inverse. So then you can say the function f equal to b to a. In this, the value of the g here, what value of the g here? F inverse. Means function f and g having the relation is the inverse relations, because this domain relation the codomain 1 1 on 2, and this relation b to a having the 1 1 on 2 also. This is called the invertible function. The composition function and invertible function, two things here in these topics. So you will be understand the things of the one by one here. So what is the first you solve the question composition function, then you solve the questions of invertible function. How to find out the function invertible? If GOF is equal to invertible identity function of the x. X means domain part. What is the GOF here? Domain part. Or what is the y here? Is the domain part y here. F here always here function a. The domain part here relation function of a. And this is the domain part here function is g. So this is the b here. The y always this is the domain part here y. This in first function this is the b here codomain, but second function of this is the domain part of the b. Then you write here for this identity function of the y. It means value of the GOF equal to x. Suppose value of the GOF is equal to x and value of the GOF is equal to y, then you can say function is the invertible and one onto function. So those function is one onto, then this will be always in the invertible function. Yes, note down it. Then next part. Yes, student, I am taking the first question of the exercise 1.3 from NCERT book. This is the first question of this. In function here, f function here, 1 to 3 having the relation 1 to 5, and function g having the 1 to 5 relation the 1 3. Given by what relation of the function of, this is the relation of the function here, this is the relation of the function g. What things find here? You will find the GOF. First you find the GOF, then you find the fog also. So you will find the one by one here. What is the value of the GOF and what is the value of the fog? Both will be different. What is the value of the fog? And GOF and fog, both you will find here. The first, what things given here? How to find out the GOF? How to find out the fog? The first you will find the GOF. Meaning A to C, direction of the GOF means direction A to C. So then first you will write here what things are given. Now start the solution here. So what is the relation? Define the function. Defined relation are equal to 1 2 3 5 and 4 1, and defined relation g equal 1 3 and 2 3 and 5 1. Then you will be not down here, means having the relation f1 equal to 2. What value of the relation f1? The relation will be equal to 2, and f2 f3 having the relation here 5, and f4 having the relation here 1. Means the image of the one, image of the one and 2, 1 is having the relation of the 2, 3 having relation of the 5, and 4 having the relation of the 1. And similarly, what value of the relation g? G1, value of the g1 here 3, value of the g2 here equal to 3, and value of g5 here 1. So this condition function relation f and g is having the relation in this way. Then you will find here the GOF. Now how to find out the GOF here? GOF f. Function f already is x, GOF x. So then you can write here GOF x. What value of the fx means GOF 1. What value of the first here? 1. So then you can write here GOF 1. So then value of the f1 is equal to 2. Value of the fx, x place you can write here 1. First you write the x What value you have? The first value here is fx plus here 1. So value of the f1 equal to 2. So value of the f1 equal to right here 2. And then you check in the function of g2. What value of the g2 here is 3. So this will result here your 3. Next, second you will find the value of GOF 3. First of all, you will write in this form. Don't directly write your answer f3. First, we will write the function fx. Then you write in this form. This is the bracket. Then operation of the function f3. What value of the f3 here is 5. So then you can write here g5. And what value of the g5 here? G5 relation is 1. Next things. Then last here f4. So you will write here GOF 4 means g operation 4. Then you will write here value of the f4 function. F4 function is 1. So g1. And what value of the g1 here? Now look at g1 will be having the 3. Then equal to here 3. It means your answer is GOF equal to what value of the GOF? This value means 1 having relation is 3, means this one having relation of this 3. Next 3 having relation is 1 and 4 having relation here 3. This is the result of directly A to C. What is the meaning of the GOF? Relation of A to C means this portion having relation of this portion. It means 1 having relation here 3 means this 3. 2 having relation of the 1 means this 1, and this 3 having this 4. 4 having the relation here, 4 having relation here f4. They are having the f4 values here. Then f4 having the 4 having relation is the 1, the 4 having relation is the 3. According this way, here and this relation here the 1 3 4. This is the relation here the 1 3 4. This is not 1 2 1 3 4. Because here 1 3 4. This is right in the answer book 1 3 4. Then the 1 3 4 direct relation 1 3 4 in the domain here, the 1 3 4 domain here. That means this one having relation is the 1, this one having relation is 3 first. This 3 having relation is the 1, this one, or this 4 having the relation here, this 4 having relation is the 3. That means 3. This function is called the GOF function. It means value of the GOF is 1 2 3 5 and 1 having relation 3, 3 having relation the 1, or 4 having relation the 3. This is the value of the A to C. The value of the GOF is. After that you will find the fog. How to find out the fog here? First note down this, then we will find the value of the fog. Yes student, then first part you have completed here, how to find out the GOF. So this one is the result of the GOF here. The result of the GOF here 1 3 3 1 and 4 3. Then how to find out the value of the fog? Then we will start in the solution of the second part of these questions, how to find out the relation of the fog. Fog Y. So this, first of all, we will write the question in this form. What value of the Y here first? 1. G1. Value of the Y here G1. Then you will write here F. What value of this G1? G1 value having the 3. Then we will write you will check the F3. What is the F3 here is the 5. This one is called the 5. Second value, first of all, when you find the fog Y, this is you write first value of the fog here 1, and you put in your value of the 1. This is a double bracket. And then what value of the G1 here? The value of the G1 here 3, then you write here F3. Then you check what is the function in the F3 of this one, the 5. Your value of the, when you put in the 1, then result 1 having the relation is the 5. Next, second, what value of the second here? 2. Then you will write in this form question for. Then you write the value of the G2. What value of the G2 here? 3. You will write the function, you will write the G2 here 3. Then what value of the F3 here? F3 value here is the 5. Means when you write the G2 value of the G2 here 3, you place here, then you check the function F3. What value of the F3 here? This is the relation of the 5. And last value here is the 5 here. For 5. Now check G5 here. G5 value the relation is 1. Then you get F1, you check the F1 you get relation is 2. So now you check this. What is the result of the for? Inverse relation of this. So 1 having relation of the 5. Next 2 having relation is 5 and 5 having relation is 2. So now you check this, 1 having relation 5 or 2 having also relation is the 5 and 3 have 5 relation is the 2. That means this is not the 1 or 1 to function. Suppose this is the 1 having 3, 3 1 having 4 having. This is the 1 function or onto function. But then for will be not is the 1 and onto function. This is the opposite of this. Suppose this one is the 1 onto function, but this will be not 1 onto function. Because 1 having relation 5 and 2 having also relation is the 5. So this will be never be the 1 onto function. But here 1 relation, 1 having relation 3, 3 having relation is the 1, means 1 not having the 1 and not having relation any other. 1 having 3 and 4 having here the 3. Then it means the yes, not look here, but this is not the 1 on the function because the relation or the function is G is not 1 function, because 1 having 1 relation but 2 and 5 not having the same as 3. But then it is clear कि function G is not 1 function, but then GOF is not also the 1 but fog will be not also the 1. But sometimes GOF may be the 1 onto function, but this will the always opposite of this fog. GOF and fog will always opposite of the fog. Suppose this anytime this GOF will converting the 1 onto function, so this will be not make the 1 onto function. This is the opposite of this relation. Yes, not on you. Then next part. Yes, student, question number 2 from NCERT book here. To find GOF and fog if fx equal to mod x and gx equal to determinant of the f5x minus 2. The two function here given, fx equal determinant mod x and what value of the gx here? Value of the gx here determinant 5x minus 2. What things you find here? You will find here GOF and fog. Both the things you will find here. So how to find it you? The first thing you will find the GOF here. Now start the solution. GOF. First thing you find the GOF x. First of all, write the GOF x function in this way. What value of the fx here? The value of the fx here mod x. Then you can write here GOF mod x. Value of the fx here. What value of the fx here? Mod x. This is the converted in the gx. This is the converted in the gx. What value of the gx here? Mod 5x minus 2. This will be right here mod 5x minus 2. This mod already right here. This mod having the only the x. or this mod, this is in the given question in gx. So this mod and this mod is different, or this mod only for x. So this is the value of the gof. Second thing, what is the value of the fog y? Then you will write first fog y. That not right out. Then you can write here what value of the gy. So then value of the gy here, gx or gy, you can suppose you write x, y, this is not matter, then you can write your x and y, this is not matter, but fog always write in form of the y. But here write the x, then you can write your x. So what value of the gx here? This will determinant of 5x minus 2. Mod 5x minus 2. Mod 5x minus 2. Value of the gx. Then you can write the what value of the fx. This is the mod x here. So you can write here this double mod 5x minus 2. Then you can write here single mod. This is not matter. Mod double and single. You can write converting the single mod here. So 5x minus 2 having the double mod, because one mod I is having in this form fx. X already having the one mod here, then you convert in the double, then convert in the second. So this is your answer of the fog, and this is an answer your gof. According this way you will solve the every questions. Then second part also here, this one is the first part. In the second part here, what is the second part here? Second part given in the fx, suppose fx value of the fx equal 8x cube and value of the gx equal x cube. How to solve this here? You will solve same techniques here. First you will find the gof x, then you can write here. Then you can write here if gof, first you write the form here gof fx. Then you write the value of fx. What value of the fx is 8x cube. Then you write 8x cube. Value of the fx here, 8x cube. You write the gx. Then what value of the gx? Then you write x cube. That means you will write your answer 8x cube into 1 by 3. The answer will become here 8x cube, only x cube here. Exponent having only here x cube, but not having the 8, then you write here 3, the 8x. This is your answer, 8x. Next part here, you will find here gof. The first part here you have find the gof here fx at g. So this is the 8x cube. This is gx. This portion is the gx. What value of the x is x cube. Then you will write the exponent outside of this gx. This is 8x cube is the only form of the x here. The x cube. Then this will convert the 8x cube into 2x ka whole cube. Then cancel 3 by 3 here. Then the result will come the 2x. After that you will find the fog x. Then you will write here fog x. What value of the gx? Value of the gx here x 1 by 3 cube and x cube. What value of the fx? You will check the fx is only x having the 1 by 3 power, not having the 8. Then you will write here 8 x 1 by 3 into 3. Then answer will become 8x. This is your answer. 3 will cancel here, then answer will be 8x. Means first what value of the gx? You check this x cube. Then fx, or what value of fx here? Power having the only x having the power 1 by 3. Then you will write 8 not having the power, 8x cube. Then result will be 8x. Yes, note down you. Then next part.